So with all these three-dimensional figures, you can also put them together to make a composite figure. And then when you're similar concept we've done for area before, you can break a figure into shapes that you know and find the volume of each shape separately and then add them together, and that will be your total volume. So for this example here, we have looks like a cube and an oblique cylinder on the top of it. So you can break those into two separate, find the volume of the cube, find the volume of the cylinder, add, and that will be your final answer. So the volume of find the volume of the figure round to the nearest tenth. So the kind of tricky thing here, it seems like almost they don't give you enough information. But we do have a circle base that fits perfectly in this cube. So if the radius is 5, then really we know the dimensions of this cube. That means 5 would have to fit in there twice. The diameter would have to be the side length here. And it's a cube. So all 3 dimensions are all 10. Which means if that cube has a height of 10, that means that the cylinder says that whole height's 22. So if the cube is 10, that means the cylinder's got 12. You can find the volume of the cube. I'll do that first because that's really easy. Length times width times height. 10 times 10 times 10. And then we have the cylinder. Which would be the volume is the area of the base times the height. So the base is a circle. Area of a circle is pi r squared. So 5 squared is 25. Times the height is 12. So that's 300 pi. Which is about 942 cubic feet. So the volume altogether, you just add those together. 1,000 plus 942 is 1,942. It's pretty much the same concept for this one. We have 2 congruent cylinders and 2 congruent triangular prisms. So the nice thing is, once you find the volume of one, you know the volume of both. The height, let's see, the triangular prisms are each part of a cube that was cut in half along one of its diagonals. So if you put these 2 together, you get a cube. The height of each cylinder is 6 times the length of the radius. Use the measurements provided to estimate the volume. So here we're told the area of this circle, which is the base of the cylinder, is 36 pi. Which means that the radius, since area is pi times radius squared, the radius must be 6. So that would be 6 times 6 is 36. So the radius is 6. Which means for this triangular prism, that whole distance across is 12, as well as this, because I said it was part of a cube. So this is 12, that's 12. And if it's part of a cube, that means that the height was also 12. So the two triangular prisms, which together makes a cube, that's got a volume of, think of it as a cube, 12 times 12 times 12. 1728. 12 times 12 times 12. And we're told the height of each cylinder is 6 times the length of the radius. So if the radius is 6, that means the height is 6 times that, which is 36. So the volume of the cylinder is going to be the area of the base, which is 36 pi, times the height, which is 36. So 36 times 36 times pi, so we'll use 3.14. And there's 2 cylinders, so we're going to double that for the 2 cylinders. And we already found the 2 triangular prisms because together they made a cube. So we're going to add the 1728 and then the 4069.44 twice. So the 2 cylinders plus the 2 triangular prisms all together, 9866.88. It says to the nearest tenth, so let's make that be 0.9. So we have to do 2 cylinders. We already had the 2 triangular prisms. Add that up to get 9866.9. So here we've got a little piece of a pipe. It has an inner cylinder and an outer cylinder. It's basically the way you can think of it, because they hollowed out the middle of it. That's why it's a pipe. So to determine the volume, find the volume of the large cylinder, and you can subtract the volume of the small cylinder from the inside. Or you can find do that with the circles, and then just times the height. You can do the area of the large circle minus the area of the small circle times the height, or you can do volumes separate. So what I would do is the large circle first would be radius 1, R1, squared times pi. That'll be the area of the large circle minus the area of the small circle then you do times height. You could actually simplify that a little bit because you can factor out the pi. So if you wanted to, another way you could write that, I'll pull the h to the front. Or if you did it all in volumes, it would have worked out the same way also. You would have had the volume of the large cylinder, which would have been pi r1 squared times h, minus the small cylinder, which would have been pi r2 squared times h. So any of those three work. Just depends on how you want to think about it and how you wrote it down. So this one's a little bit complicated. We have two cylinders with equal volume and two triangular prisms that make up the hand of this robotic arm. So we are told that the volume of each prism, there's two of those, is 1/2 radius times 1/3 the radius times 2 times the radius, where r is the radius of the base. So what fraction of the total volume do the hands take up? So this is the volume of the hand. Now there's each prism, so there's two of them. So we're going to do 2 times 1/2 r times 1/3 r times 2r. So if you multiply that out, it's 2/3 r cubed. So then we need the volume of the cylinder. Let's just say r. So then we need the volume of the cylinder, which would be pi r squared times the height. And there is two of them. So just multiply that by 2. And it said write it as a fraction. Unfortunately, it doesn't simplify a whole lot, but you put the hand over the two cylinders. What fraction of volume does the hand take up of the total volume? So here's the hand. 2/3 r cubed. And then it says of the total volume. The total volume would be the two cylinders plus the hand. And there it is a fraction. That could be simplified a little bit, but that's the idea. If an oblique cylinder and a right cylinder have the same height but not the same volume, What can you conclude about the cylinders? So Cavalier's principle says that if they have the same height and the same cross-section area, then they have the same volume. So here they have the same height. They don't have the same volume, which means they don't have the same cross-section area. So that means the circle for one of the cylinders is larger than the other one.